All right, so welcome everyone. Today we will be covering conditions and loops, right? Let me make sure I'm not a liar real quick. Yeah, today we'll be covering conditions and loops. Conditions are very simple. If this, then that. Pretty simple, but we'll cover how to actually write the code. And then we'll also cover loops. How do you do things hundreds, if not thousands, or even millions of times? And yeah, we're going to do that today. But first, some review. So we already did review of this is the method signature, this is the method body. What do we call these? Parameters, yes. What's a less vocabulary term way to call them? Yeah, arguments. Parameters, arguments, inputs, these all work. And what is this? Yep. And let's see. Not you this time. What is this? Well, yes, but within our code, what is this spot called? Yes, the function name. And let's see. What is the relationship between these two functions? Begins with an O. Yes. Overload. Overloading is when it has the same when you have the same function name but different parameters. It is technically a different function signature, even though they have the same name. So this is possible and quite okay and useful. You can even use the other function inside the overloading function. So nice little shortcut. You don't have to write so much code. That's about it. Oh, we also covered data types and variables. What's the difference between an int and a float? Or there's many. Tell me one. Yes. Correct. So what's the difference between a float and a double? Not you this time. Because you know all this already. I know you do. Difference between float and double. Does anyone remember? The hint is in the name of double. He's thinking about it. Yeah, it's twice as big as a float. And that's about... The rest is not super critical. But yeah, does anyone have any questions about things from last week? Or is it so far away in your mind right now that you're like, eh? Yeah. Last week we did variables and methods. So how to declare a variable, how to initialize a variable, how to do the two steps in one. We covered various data types: Boolean, int, float, double, char, and byte. Char is a single character. Also note that a string is a string of characters, a series of characters tied together. A byte is basically 8 bits of data. A bit is a 0 or a 1. Bytes is often how you refer to storage on a computer. So when you see kilobytes and megabytes, those are just aggregations of bytes. Double and float are ways to store decimal numbers. Floating point and double you must be careful because they only store so many digits. So if you need a very precise representation, you should probably use big decimal. However, a double is twice as precise as a float. And an int is an integer or a whole number, a number without a decimal point. And Boolean is true or false. That is it. Good question. I probably should have covered that. And then with methods, again, this is the method signature. This is the method name. This is the type that the method returns. The type can also be nothing. The method can return no output. and that's void. We can give the method inputs or parameters. Each parameter must have a data type and it must have a name. So in this case, whatever is being called to add, for example here, actually that's using floats, not integers, so it would call this one. A gets set to the first parameter, B gets set to the second parameter. And then you can use them inside the function like this. Okay? Good? Cool. All right, so let's move on to today's lesson. As usual, create a new folder. And oh, I should have done that before. So create a new folder for today's work. And what do we let's see, is that May intro? June variables? All right, so we're going to do June conditions and loops. All right, so file. Project, sorry. Add folder to project. Alright. Oh, okay. Let's take a look. Okay. So create this file, let's save it. We're going to save it as conditions.java. Okay? So given that we're calling our file conditions.java, what is our file going to look like at first? Can anyone tell me off the top of their heads? What's that? Variables. Nope, nope, nope. Try again. Hey, uh-oh. Take a look at our other. Oh, you weren't here last week, so let's compare. Sublime text is in fact not Atom. I was using Atom all day today, so I'm kind of messed up. So given last week's code, what would our... Yeah, there we go. Cool. And now, I don't want to give that away. What is that? Control. What was the shortcut? Alt-Shift-1. Cool. Who remembers this? Yep. Ah! Yeah! Look at this guy. He's pro. Again, I expect everyone to have that memorized, like we said last week. So next week you can't answer, but that was awesome. But you guys got to memorize this, okay? Okay, so today we're going to do conditions. Like I said before, conditions are if-else. Super simple. The way this works is, well, I'm just going to show you. So we can say if, and then open parens, true, and then curly brackets, okay? This is what a condition looks like, okay? It's the same exact thing as C. C, Java, same. Except I don't know if true looks like that in C, but whatever. So, I'm sorry, I didn't hear you. Ah, okay. So slightly different. Thank you. So this is a condition. If whatever is in the parentheses eventually is true, then this will print. If what is in here is false, it will not print. Let's demonstrate. Except I don't have a command line open. Ah! June conditions. All right, so actually first, everyone get this so far. Has everyone gotten this written down? Yes, 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 yes. Cool. All right, now let's compile it. Actually, better yet, who can tell me how to compile this besides Anthony? Then what? Yep. Oh. Oh. It is like C. My mistake. It's lowercase t. It's been a while. I was writing Python on Wednesday, so I'm all confused. There we go. Okay, now if I want to run it, what do I type? Java what? Yep. .java? .class? Nope, nothing. Correct. Okay, true is true. Good, so that works. However, what will happen if I change this to false? Correct, nothing should happen. So if I change this to false, and I compile it again, nothing happens. Okay? What is here must eventually be true, or this will not print. Okay? So we can do true or false, but that's not interesting, right? We can make it a little more interesting. We can use variables. So we can do Boolean is true, and we can set that to true. And then, again, this is just showing off variable substitution. Very basic things, right? But we can put a variable in there. Whatever value is in there will be unpacked and then checked. So doing this will end up printing true. True is true. Okay? Because the value true just gets substituted in here. All right? Questions so far? What's up? Sure. Oh, so he's got spaces in his directory. Oh, where this file is stored? Yeah. You didn't do the project thing, man. Come on. So it's on his desktop. Yeah. So just like before, on your go to your terminal. Spotlight. Or down here. Down here. Okay. So CD desktop. Nope. Nope. CD space desktop. Yep. Then what's your folder name? Yep. CD. Tab. 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 Just tab it. Whoa. Yep. Enter. LS. And oh, you've been doing it all in the 01 intro folder. So CD 01 intro or CD 0. So CD. No. I keep telling you not to do that. So CD takes you back to your home directory. So now you're back to the beginning. CD takes in one argument, which is the directory to change into. Okay. So do ls. Right. These are all the directories in your current location. You want to go to desktop, so you do CD1. Yes, there you go. Yep. Now you want to go into the L2 code. So what do you do? That's not a command. What is a command? The one that I told you not to type alone. So CD is the command. You want to type that, but you don't want to type it alone. So CD literally tells the computer change directory. Just giving it a folder name, it doesn't understand. When you're typing on command line, it needs a command. So you give it a command, and then the CD command wants a location. So if you don't give the location, it assumes you're going home. Yep. 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 You can tab complete. You don't want to do a space. So I strongly discourage spaces in your folder names because of obvious trouble. Do tab. Yeah, because otherwise you have to escape from using a backslash. On command line, yeah, try not to do, yeah. Because what happens is spaces on command line are used to separate commands. So when it sees a space, it thinks you're doing a new command. So putting a backslash in front of the space says, hey, we're not doing a new command. This is a literal space. So 0, 1 space Asia. 0, 1 is not a command. There you go. Now that won't work because space is special. You have to escape the space. So CD space 0 tab, just tab, and now you see it puts a backslash in front of the space for you. Yeah, now hit enter. LS. Now you're where you need to be, right? Yep. Conditions are job. Okay, cool. You're good from here. At the end of no problem. At the end of class, let's sit for a few minutes and we'll go over command line because you need to have that really down. So we'll fix you up. Yeah. What's up? 뭐예요? 맞아요. Java. So 이번 윈도우 애플리케이션이에요. Java가 윈도우 애플리케이션 아니에요. command line 애플리케이션이에요. command prompt에 only 어떻게 말해요? only 오지? command line 애플리케이션이 command prompt에 오지 있어요. Did that make sense? Okay. So 언제 이번? No good. 보여요? 어? command prompt and gone. Okay. So real quick. He needs to be in the directory where this file is. Can you tell him that? Yeah. Okay. All right. So, has everyone got their application compiling? I know he's working on it. Looks like they're working on it. Everyone else is compiling? Yeah? Good? Okay. What was I doing? So this works, but it's kind of boring. It's not useful. The world is very rarely only true and only false, right? So there are other ways to do these sorts of conditions. So we can do 10 greater than 5. So we can do something like this. Now, I haven't taught you this yet, but I think you're smart enough to figure it out. What does this become? Yes. Whenever you have a comparison operator, it evaluates, basically becomes calculated, and then it becomes either true or false. It becomes a Boolean. Okay? So this becomes evaluated, in this case, to true, because 10 is in fact greater than 5. If we were to compile and run this, we get 10 is greater than 5. Let's actually bring this up a little bit so people can see better. All right. Questions about that part? Yes, no, maybe? Are you bored yet? Now, there are other operators. There's also, you have the greater than operator, the less than operator. You have the double equals operator. Okay? This checks for equality. Double equals and single equals are not the same. Okay? A single equals is assigning. Okay? So if we were to do something like this, this would not work. We would be trying to set 5 to 5. Right? This compares 5 to 5. Okay? In this case, this would evaluate to false. In the other case, it would not compile. Okay? You also have greater than equal to and less than equal to. No, it's a little difficult to see. Let's just do this for now, so that's easier to see. Yeah, so that's a little easier to see. I'll comment it out in a second. And then there's also not equals. The exclamation point or bang is usually not in Java. Okay? So you could also do something like not true would be false. Okay? Yeah. No. This must be in this order. This does not work. This does work. Whoops. Okay, so it must be the greater than or less than, and then the equals. That order does matter. Good question. Other questions? Cool. We can do this with methods too. Now we could do something like I'm just demonstrating using a method. It's not anything fancy or special. 괜찮아요? Alright, while people are typing this. What do we got? Okay. Java C, Java Projects 3 conditions. Oh, 괜찮아요. Oh, can someone translate for me? Can someone ask if I'm typing too fast? Because things like public, return, int, all of these, it's a lot. It takes more. Anytime you're doing translations, just stress in the volume. It also, when you're working, so I work at a Korean company, and that is super difficult because all of their method and variable names don't make sense. They have to be in English though, because Java will get kind of messed up if you don't have ASCII function and variable names. So they'll have like reservation.used, right? As a method, right? I would think that, oh, that's a Boolean check to see if it is used, right? But no, what it actually does is it completes the reservation. Which doesn't, yeah. So, I guess just have to catch up. Okay, so if we were to do something, if we had a method like this, what's up? 그리고 지금 return true 없어요. 네. 오케이. method이에요. 맞아요? definition. 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 정의예요. 오케이? 그리고 execution이에요. So return true에 있어요. 2번, 2. 오케이? So 언제 있어요? 언제 있어요? 2번. Okay. Tricky. All right. So now this will. I compiled it twice. Come on. There we go. Return true is true. Okay. Whatever value that this method outputs will get substituted where the method is called. Okay? And so this returns. Now, we can also do this. We can negate it. Yeah. switches. This operator, this bang, this exclamation point, will switch a boolean. So not true equals false. Not false equals true.
Well, but I had a question. So, if 10 is greater than 5 thing, I changed it into 10 is smaller than 5, but it's still printed 5.
Did you hit save?
Huh?
Did you hit save?
Yeah, I did it. So, I made it like this. Right? Right? I still got it.
Compile again? Oh, that's because your compilation failed. The new version of it or something. You're missing the dot comment. And you're missing rerun true. Yeah.
Oh.
All right, questions about the negation operator? All right, if you have gotten to this point and you're waiting, use this time to take some notes, okay? Make comments, take some notes, okay? Again, single line comment, multi-line comment. Okay? Yes, because you made this one false. 맞아요. Okay. Questions? Okay. So that's how to do true. But what if these can be combined, right? These are just the inverse of each other. There's another way to do this. You can say else. Ah. You don't have to do a new line there. I just did it because I didn't want to have to scroll. What's up? No, correct. You do not have to. So the you're thinking of if else. Yeah, we haven't done if else yet. So else, whatever is. Why am I pointing when I have a mouse? Whatever is after else within the brackets will execute if this is not true. If this is false. If this condition fails, then this will run. Okay? Right. If you want something to run, yes. Now, you may not always want something to run, right? So in these cases, right, or we could just do if something that's false, right? And maybe we don't want something to happen, and that's okay. But in the event that this ends up being false, And if that ends up being false, then we want to take some other course of action. That's when we would use else. Okay? So this is part of a decision tree. So basically what an if does, you have your program execution, and then when you hit an if, your program can maybe go one of two ways. All right? This is what's inside the if, right? And then this is what's inside the else. If there is an else, there may not always be an else. You don't have to put one. Okay? Questions about that? Good? Good? So, there's a third thing. There's also else if. So we could do something like if 5 is greater than 10, which would be what? Correct. Else if and then now, this is where things can get a little bit confusing. This is a 3-direction decision tree. We hit an if. Okay? First, it goes down this path. Then it goes down this path. And then it goes down this path. If this one is true, neither of these runs. It short circuits. Okay? If this one is false, and this one is true, this never runs. Okay? If both of these are false, then this runs. Okay? Now here's the crazy part. You can have as many of these as you want. You can just keep doing else if, else if, else if, else if. All right, and then they'll go in order. Okay? Mhm. Yeah, so this is false. So it skips this and it goes to here. Correct. Because this is true. Correct. So this will not print. So let me try explaining it a different way. When you have a condition like this, assuming that the logic gets to that point, whatever's between the curly brackets after that will run. Okay? Now, when you have a contiguous if statement or a continuous if statement, if will continue until there's what's a good way to explain that? I haven't had to get that deep in a while. Also, I should be using the mouse. So, yeah. Yeah, go for it. The circle with 3 layers? I haven't seen that one. Yeah. I see, I see. So, versus okay. Is this kind of so actually I need to record the screen. Yeah. So basically this goes from top to bottom. So if this ends up failing, it goes to here. If this ends up failing, it goes to here. If this fails, it will then always do this because all of the ones before it failed. Okay? However, if any of them are true, it gets out. Okay? So if this one was true, for example, it would end. If this was true, it would also just skip the rest. Okay? However, something to be aware of. We have several if statements here, right? We have one up here, we have another one here, we have another one here, and so on. If statements are independent of each other. So if I have one if, it's independent of another if. Okay? What binds these two is the else. Okay? Correct. There cannot be three else's without corresponding ifs. For every if, there can only be one yes. Right. Well, else if needs at least an if. Right? The if starts things. And if each if is independent of any other. Okay? Cool. Thank you for the tip. Questions about this? All right. Yeah, we'll get rid of this too. Now, you can also nest these. To nest something is to put it inside something else. So we can do something like man, freaking sublime. Waiting for people to type. Give me a signal when you've got this typed out. we actually did that up here. There's no else for this. Else is not required. Yeah. Okay, so has everyone got this down? Cool. So, what will print here? Well, actually, I made it kind of obvious. If I did this, what would happen? So if I change this true right here, if I change this on line 32 to false, what would happen? Correct. Nothing will print. Because this condition block is inside this condition block. This won't even get executed if this is false. Okay? Does that make sense? Yeah. That is the nature of an if statement. If what is in here is true, then whatever is here will execute. If this is false, it will skip this whole thing. That's true in general. That is what makes an if statement an if statement. That is what makes it useful. If we do this, this is true, so then it starts to execute this block. Okay? It hits this line. Then it goes, okay, is this true? Yes. Then I'll execute this, and I'll skip this. You will never directly use if false. I'm just using that for demonstration. There will be times where you set variables to false. So if you had a variable like, is it hot in here? You might set that to false, but it would probably be true. Here we go. Is it cold in here? You would set that variable to true. And then later you might be, is it cold in here? Then turn on the heater. But in that case, since that would be false, you would not turn on the heater. Does that make sense? Cool. Other questions about this? Cool. All right. So, there is another way to do conditions. Remember earlier how I said you could have as many if-elses as you wanted? That can get kind of messy. You know where I'm going. Yep. So there's another thing you can do. It's called a switch case. So I'm gonna make a variable called my number, and I'm gonna set it equal to 10. Okay. And I'm gonna switch on my number. What? Typing is hard. Typing is still hard. Oh, I can watch through this to type. And then in the case that it's 1. Error tells you that 이번 없어요. 지금 해요. Error interface unexpected. Line 23. 23. Good. 23. 아, method. 아니요. string args, open bracket, close, open, close. What is going on here? Huh? Oh. Save. So, what this does, this is kind of a little bit of a shorthand. So the switch will take my number. In this case, it's 10, right? And it will go through each case. If what is here is equal to my number, then the next line will start executing. Okay? So my number is what? What did I set it to? It's a silly answer. Come on. Okay. So it's 10. So is my number equal to 1? Right. Is my number equal to 5? Is my number equal to 10? So then this will execute. Okay?
So case 1 and case 5 is false, so it never ends up true.
Majeo. Correct. So. Next to each other? Oh, you mean, oh, yeah. So if we were to write this in a different way. Oh, I see. Oh, you mean like this? What? Oh, I see what you're saying. Yeah. I'm trying to teach good style too, though. And this would not be considered good style. But this is... Yes. So, is that a little easier? Thank you. It's the same thing. I'm demonstrating. Yeah. Now, so let's run this real quick because we haven't run this in a while. Okay. 10 is 10. So that's good. However, watch this. I'm going to set this to 1. Which one of these is true? Correct. But all of them ran. This is a thing with case and why it's useful, but why you also need to be careful. Correct. So when you hit, once the first case is true, it will keep going through the rest of this whole block. Okay? Unless you break. If you break, then it will exit the block immediately. Correct. Not quite the same. It is the same if you use break. Yeah. So now with that break, you'll see it stops there. Okay? Now, if you want to. There may be some situation where once the first condition is true, you do want the rest to continue. And in that case, you would not put a break. It's very rare, but it does happen. So you could do breaks in all the places, right? So at this point, it would be behaving the same as if else. Okay? And there is one more thing. We have all these cases. If none of these cases are true, right? You can think of this as like an if, an else if, an else if. There's also default, which is basically else. Let's do something like this. Can you still read over there, Will? Cool. Is this better for you? See ya? Cool. So, if I set my number to 2, what would print? Correct. Since this is not true, this is not true, this is not true, this would execute. Okay? Default is kind of like the else. Okay? Questions about switch case? 'Cause that's pretty much it. Okay? There is one last thing I want to cover in conditions before we move into loops. Okay? We've been doing comparisons between numbers, right? It's very easy. You can use double equals for, right? We could do things like this, right? This is totally fine, right? So this works. However, this does not work. Okay? This is because strings are objects. We have not yet gotten to objects. Okay? But, just in case you start writing programs now, if you're trying to do an equals comparison with string, you want to use something like this. Okay? If you don't plan on comparing strings right now, don't worry too much about it. Once we get to objects, we'll go over this again. Not super critical. We will cover this part again later. Okay? Good? All right. So high is of the string object type, and string has an equals method defined on it. Yeah. So this is a literal object, and even though it's literal, it still has all of the methods and properties that the object has. Okay. Any other questions about conditions? If, else, switch, case, comparison operators, booleans, negation. It's awfully quiet in here. Should I get that music playing again? All right. So now I'm gonna make a new file. All right. We're gonna call it loops. Loops.java. Okay. Loops. Loops. Can someone who's not Anthony or Charlie or Will tell me what I'm going to write? If my file is named loops. Huh? Loop? Just like that? Majayo. Good. Then what? Yes! So good. Then what? Yep. 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 Yes! Well done. Okay. Everyone's got their new loops file set up? Yes, yes. Get some feedback here, guys. Come on. All right, good. Good, good, good. So, loops. There are a bunch of different kinds of loops. Which one should we start with? Which one did I say I would start with in the curriculum? Okay, cool. We're going to do that one. Do you want to move over here? I mean, yeah. Okay. So, loops. A loop So there are two main types of loops. You have for loops and while loops. Okay. First, we're going to do for loops. All right. And a for loop is composed of three parts. Well, the for portion is composed of three parts before you have your body. Okay? Your first part is your initialization. Okay? Your second part is your your continuation condition. Continuation condition. And the third part is your incrementing step. Okay? What the hell does this mean? This is the first thing that happens in the loop. Okay? This is the condition that must remain true for the loop to keep going. Okay? And then this is the last step that you take in the loop. This may not make a whole lot of sense, but it'll make a little more sense when we start typing. Oh, that's much better. Sí, 아니에요. Okay. So this part is your initialization. We're creating a variable called I. All right, and this I variable will only exist within this block. Okay? Once you're outside of that block, it no longer exists. All right? So this is our initialization. This is our continuation step, or our continuation condition. So as long as I is less than 10, this loop will keep running. Okay? Then this is your incrementing step. When each run of the loop finishes, I gets increased by 1. This is the same as writing this. Okay? Okay? Just to be super clear. All right? So, that's the setup of the for loop. Then whatever is in the body of the for loop will run each time. Okay? So when the loop starts, I will be set to 0. And then this will run. Okay? Once this finishes running and it hits the end, then I will be increased by 1. Okay? If I is less than 10, it will run again. And then it will increase I by 1. If it's still less than 10, then it will run again. And so on and so forth. So, who can tell me what this will print? Who's not Anthony? Yep. Whoops, but we're not doing conditions. Did I save? Save. Loops. Okay. What if I were to change this to 1? Not Will, not Anthony. Yep. What if I were to change this to less than equals and leave that as 0? Yes. Good. What if I did something like this? I'm actually not sure. I would need to math, but yeah. What would it print? Yep. Yep. Okay. It's actually easier than loops, than conditions, huh? Now we could do all sorts of stuff here. We could do, yeah, that's good enough for now. All right. Any questions about this? Yeah. Same. Yeah. It matters when you're doing. It matters when you're doing while. Yeah, it matters when you're doing while loops, because it will evaluate first. So when you do I++, it evaluates I and then it increments. When you do ++I, it increments and then it evaluates. In this context, this is an independent step, so it doesn't matter. Yeah. That's a while loop. Let's do that now. With Oh, does that work? Oh yeah, yeah. Huh, that's clever. I've never tried that. But honestly, like, they should probably be using while loops for that anyway. Yeah. So don't run this. Actually, you could run it, but it won't crash. It'll just keep running. This will not stop. There are cases where you want that. For example, if you're running a web server, for example, you may want to do that. Now we could do something where. So you remember break earlier? Break has more than one use. So let's say, whoa, hello. Let's do something like this. And let's say can anyone guess what this will do? Not Will, not Anthony. You guys are too smart. Yeah. Wait. Whoop, 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 whoop. There we go. Yes, now it will only run 9 times. Oh, right. No, yeah, I was right the first time. Sorry. Yeah, that will do 9 times. Thank you. Right? I don't know. That'll do 10 times? No, because it'll do, right, because it'll stop after I wanted this. This is what I wanted. Thank you. I'm the kind of guy who just keeps trying shit until it works. So I usually don't think that far ahead, but that's better practice. Okay? So if we run this now, oh, get wrecked. Damn. I was hoping it wouldn't happen. Right? There we go. However, this is very similar to a for loop. You have your initialization step. You have kind of the more of a termination condition than a continuation condition. And then you have your incrementing step. We just wrote a for loop using a while loop. We could also make it simpler if we did something like this. This is exactly like a for loop. Okay?
Okay, so from that one, I got rid of my break, but it's still stuck at 10. Oh, no, never mind. Oh, yeah, this is crazy.
You didn't save, maybe. Or didn't compile or something. Alright, any questions? Questions? Yes, no, maybe? Okay, now, thing with a while. If this is false, what will happen?
It will never run.
Correct. It won't run even once. Okay? However, let's say we wanted it to run at least once. We always want it to run once. And then maybe we want it to loop. You can do a do while. You can do something like, we're going to set j back to 0. Let's just do this again. Actually, let's do slightly different. Let's do this. There we go. Let's also do this so people can see. Cool. So this is also the same as that for loop. Okay. If we ran this, see, we'll loop through j twice. Okay. Now, I'm going to also do the second j, so that way we can distinguish it. If I did this, is j ever less than 0? No, correct. If I run this, it'll still run once, because we did a do while instead of a while. So it will do it once, and then while the condition is true, it will continue. Okay? Questions about that?
This time we don't have to put, int before j.
Yes, because j was already declared. Yeah. If you try to declare a variable twice, it'll complain. And by complain, I mean explode. Other questions? What else were we going to cover today? What's that? They'll get easier. We're not going to do a for each loop today because I haven't taught you guys arrays yet. I don't know why I put that on the curriculum. It should be under arrays, but oops. We'll do for each later. Or we could. We only have 25 minutes. Maybe I should have taught arrays before loops. Oh well. Let's do. We should do some exercises. But I'm an idiot and I did not prepare exercises. So. Huh? Yeah, I don't want to. We're not going to cover arrays in 25 minutes. I mean, we could do raw ways? Raw. Oh my god. We could do raw arrays in 20 minutes, but not like array lists and hash maps and all that. Now I would want to cover all of that together. So. We could do. Here we go. In 10 minutes, and I'm going to set a timer, I want you to write. I'm going to make it super challenging. Okay? In 10 minutes, I want you to write a for loop that prints, or that runs from 10 to 0. Okay? And it prints whether or not the number is even. So go from 10 to 0. If the number is even, print this number is even. If it's not even, print this number is not even. Mm-hmm. And I'm actually going to give you 15 minutes. Okay? Okay, cool. Set a timer for 15 minutes. Man, it is all sorts of messing up on this today. There we go. Good. Start objects. Actually, if you look on the meetup page, there's a link to this document. It has our plan for the whole class. We start objects July 1st. And that's when we also start using an IDE. We're going to use IntelliJ, but if you want to use Eclipse, that's fine too. And we'll do objects. Then we'll go on to inheritance and things like that. Following that, we'll go into abstract and static. And then I made a little text adventure game. I'm going to take out certain parts of it and have you guys finish it. That's kind of like a final practice. And then at that point, not for true beginners. Like if you know how to code already, no problem. But if you've never written code before, you're gonna have a bad time. So what we're gonna do is we're gonna teach all the programming basics and then move into actual development. And then if people, well, I don't want to plan too much farther out than that. Yeah. We actually have a guy who used to lecture at the university in as your advisor, who's actually developing our curriculum at the moment. Oh yeah, cool.
Well, it's not a lot of my major's linguistics, so we have to analyze it.
That's awesome. That's super cool. Hopefully you get to meet with him. He's a smart dude too. He does like lots of web security stuff. Like they're building kind of an integrated browser for Android. So I wanted to show him that. He lives here. Well, he lives down in Seoul. So done. Damn. Let's see what you got. Oh, I'm so sorry. I made an assumption.
Do they know modulo?
No. So, in English, when you say a number is even, that means it's divisible by 2. So even numbers are like 2, 4, 6, 8, 10, 12. Those are even numbers. I'm sorry. So this is what I mean by is even. Is the number you're looping through divisible by 2? Sorry, that was my mistake. I should have been clearer.
Why?
Oh, okay. Use, yeah. I didn't teach them that yet. But
Do modulation.
they can do it without it. That's going to kind of be like the bonus part of today's lesson. Modulo. Ooh, hey, can I get my cable?
Oh yeah.
Oh, nope, nope. Yeah. Yep. As I do that.
Can I just go like do I need system over here?
So your loop part is correct,
Right.
but you still need to check if it's even because it's not.
I know.
Okay.
So I don't have to put system over here.
Not yet. I would worry about the even part first.
Then do I just put in
You only need one loop.
one?
I'm only asking you to loop through it once. You don't need that while
Then
once.
do I don't need while loop?
Yeah, you don't need this part. So for and while are just 2 different ways of doing loops.
Oh.
Yeah, yeah. So you can, yeah. There you go. So now do your even check.
Even check?
Check if it's even.
If it is divided by 2, right? So
There you go.
no. Oh.
Come on.
Oh wait.
Start typing.
So, okay, can you just tell me what to type first?
No?
Around.
Look at the code you've already written.
I put while. That's not even. This
No.
one, maybe this one.
Your 4 stuff is done.
Is that
We taught 2 things today.
condition?
Yes.
If? Oh. Wait. Oh, okay. Oh, so under 4, can my if start from here?
Yeah.
If true.
What is true?
I divided to
Start typing.
why doing the person
That's so you can do that, but that is not what you want. Also, the otherwise print that it is not even. So in this case, you're skipping the odd numbers, but we don't want to want that. When the number is odd, we want to print that it's not even. So you still need to go through each one. And then I'm going to show you a keyword. Are you ready for this?
Can I switch? Can I switch?
You can, but that's like using a sledgehammer for a tiny nail.
That's what he said. That's all like that. That's being snaky. Oh yeah.
All right, guys. So I'm going to give you a hint. I'm going to give you a hint. All right. If I were to write this, okay? If this was even, what would be the result of this? If I was even, what would be the result of this?
There would have been like no remainder.
0. Right. If, or sorry, it would be an integer. Right. Maybe I should have taught modulo. Alright, so I'm going to give you guys a hint. A major hint, because I overestimated some things. So, you know plus, minus, divide, star, right? These are all operators. There's another operator, modulo. Okay? We're going to go right up to the end of this. Modulo prints the remainder. Okay? So if I did 5 modulo 4, this would end up as 1. Okay? If I did 11 modulo 5, what would this be? No. 1. Good? Okay. This should help you.
Okay, so the person thing,
Yeah, because the typing messed me up.
2, right? I like integer, the integer
To do, yes. Yeah, but it's really complicated. Because you have to convert from your primitive int type to a primitive byte. Or actually, no. I think you can directly cast. You can directly cast. No, you would have to cast to an array of bytes, and you have to use libraries to do that, or build Java libraries to do that. It's part of the standard library that you can do those sorts of things, but it's complicated. Convert an integer to its bit value. Yeah. But you can do it. You just have to start using like the standard library to do it. It can't be done with just normal primitives. Because you have to take your integer, because your integer is a collection of bits, which is also a collection of bytes. Right? And so you have to convert to an array of bytes. Or an array of bits if you want to get super fancy. But even then. Does that help? Oh, okay. That should help a lot. In this case, you're just doing a comparison. You're checking if these are equal.
Oh. Oh. Equal if there's one equal, it's more like saving,
Yes.
and double equal means checking the value.
So I see. Alright, Control C.
Control C?
Control C terminates whatever's currently running.
Oh, yeah.
All right, folks, time is up. All right, everyone. So, who got it working? I didn't actually get it working, so. All right, let's do the answer real quick. Ah. You could have done greater than 0, depending on how you interpreted that. Whatever. Okay. Does everyone have something like this? Yeah. Yeah.
It didn't work when we put the I before the, well, the I was before the string, and there was no space between the plus. Does that make a difference?
Wait, say again? Just say it again. I didn't.
Because we made it so it was 10 and 9 is odds.
Oh, yeah, it should start with a string. So what'll happen is so in Java 6 and below,
One other thing.
yeah.
You say that, but we got it to work, and now it starts with the integer,
Really?
and it still prints.
Mine started with
Maybe that's a Java 8 thing. Cuz I know in Java I think 6 and below, you had to explicitly, maybe it was 5 and below. You couldn't add a string and an integer. It'd be like, what are you doing? Stop. In Java 6, they did autocasting, where if you tried to add an integer to a string, then it would autocast the integer to a string. And then I think it might have been an 8, where if you have the integer first, it'll still work, maybe? I don't know. But, yeah. Yeah, you can also do, like, I think it's like print f line or something like that. That doesn't do a line, though, does it?
You put a backslash, and that will probably work best for him since the program specific.
There's not a print. There's not a print f line.
No, it's just not.
Really? I guess so. Okay.
And in print F, you have to explicitly put a backslash and the I.
Gotcha.
Okay.
What's that?
Oh, never mind.
You couldn't do this? That should work. Ah! Yeah, same thing. So that's just another way to do print. But yeah. There we go. Yeah. So does anyone have any questions about this? Yeah. Oh, damn. Okay, so how would you handle that?
you can just change it.
Oh, get wrecked. Oh. So we should do something like ah. There you go. So yes, good. Good point. We know who our mathematician is now. Yes, very good. So, good job, everyone. Today we covered for loop, or today we covered if conditions. We covered if else, if else, if else. We covered switch case. We did for loops, we did while loops, and we did do while loops. This is a lot of logic, but we all got it done in one day, in 2 hours. So next week we will cover. Next week we will build a calculator. Okay, you're going to build your own text calculator, just kind of as practice. Okay, and we'll spend the whole time doing that. Following that, we'll resume with lessons. We'll go into collections where we do arrays, lists, maps, basically ways to store multiple pieces of data into one structure. So yeah, thank you all for coming. We're also going to do a social event soon. I was supposed to schedule it for next week, but I suck and I forgot to do it. So I'm going to schedule a social event soon. And we also want to find out ways to make this more social, because sitting here and just listening to me for 2 hours is not super fun, doesn't help you make friends, all that good sort of good stuff. So if you have ideas, tell me. I want to hear them. But thank you for coming, everyone.